So this is an example of a real M-series fan-out wafer. You can see shiny silicon chips on the back.
Deca is a global leader in advanced packaging.
Congratulations. Congratulations.
Ganpati Bappa! Let's have a big round of applause, everyone.
Welcome to India one more time.
Can we have a round of applause for everyone?
Welcome.
And express and explain that what RRP and Deca are doing today, probably, with all due respect, is not yet being done in India, and probably for many more months. So Deca, while we all know that the state government has approved our project of 12,000 crores for OSAT, which they give $1.5 billion US, and the second phase of 24,000 crores, which is $2.5 billion of setting up a fab. This was approved by the state government, and we've already started our OSAT facility on the 18th of September under the blessings and guidance of our strategic investor Sachin Tendulkar, who graced the occasion the other day, and since then his blessings has taken us to a different level. But coming back to what Deca and RRP are going to do is something different. So, which is why Tim always told me that, we will not call this as an OSAT facility, but we will call this as an advanced application foundry, actually. So, which means that we will be doing something which is a very unique technology, which Tim is going to explain more, and which is what we do, something which is called as adaptive patterning, and which will add a lot of value to our setup in the coming times. A complete automated facility, which we should be starting work in the next month or so, and within 9 months we should have this facility up and running. Coming to the visions, I think everybody has a vision, and we all have to have a vision. RRP always had the vision under the blessings of our mentor, Dr. Anil Kakorkarji, that we need to create something different than the others. Most of the semiconductors facilities that are presently being targeted to set up their OSAT and the foundry, and obviously now the central government is also promoting compound semiconductors as one of the fab setup, which obviously has a lot of applications. Our vision is something different, and the vision is always defined by an altitude. It can go higher and higher and higher. So we are going very high, very high. So much so that if somebody is thinking of a drone, we are thinking of a satellite. So that's what our altitude of vision is. And this is only possible because of the technology that Deca is bringing into India. And so we have to give a round of applause, a warm welcome to Tim and Robin to have come all the way and brought this technology, which is almost, Deca has been a founder, Tim has been a founder for almost 3 decades, probably maybe more, but India, under the leadership of our Honorable Prime Minister Modi ji, who actually has brought this concept of the subsidies into India, has now helped us to get a technology which is readily available on our platter, which otherwise, with all due respect, would have taken India probably another decade to set it up. So we have to really thank them to have unconditionally come ahead. We are signing an official MOU today. We will be doing a technology transfer license agreement, and we are hopeful that we should have a complete automated plant by the end of this year. And such plants, Tim obviously thinks that we can generate a significant revenue of starting from $30 million per year. I will not talk more about the technology because it's his property. When we sign the TTLA, we will be partners, but right now we are still partners. And I will wish all the best to my team of my college friend and the one and only one who could make this possible of setting up the OSAT facility, Mr. Prashant Deshmukh, wonderful gentleman and a very powerful technocrat. He speaks less, he performs more, we speak more, we perform less. And obviously aided by Prashant, by Shikhar, Apurva, Virendra Singh, LM Singh, Israr, and the entire team. I can see Bala also over there, who is a specialist wire bonder. He's been imported from Chennai. So thank you very much, and I think I will now hand over the stage to the guest, the host, Mr. Tim, who is actually doing a fantastic job. Thank you very much.
Mr. Tina, sir, let's have a big round of applause.
Thank you, Raj, and everyone. I very impressed by this gathering. I had no idea we were so large. Raj. Very nice to see you all. I think what we're doing together, Deca and RRP, is creating the future of India. You guys are going to be at the forefront of the most advanced packaging, advanced interconnect that goes in Apple iPhones, it goes in automobiles, it goes in satellites and drones, all types of things. So it's a great opportunity for you to get a leap ahead as we bring this up. Forward, can I show my slides? So I have just a Semiconductor was one of the leading pioneers in Silicon Valley in the US. That's TJ Rogers in the blue jeans next to me in his vineyard. And our first round of funding was $100 million, but quite a bit for a small startup. And SunPower, who was the #2 solar power company at the time, also invested in Deca. And some of the processes that will be implemented in RRP actually came from SunPower, from the solar industry. It's kind of an interesting situation. In 2013, the Gray Farm, we introduced the two technologies that we're talking about today, which is the M-series fan-out and adaptive patterning, which is a real-time EDA system. It's the only system in the world that designs during manufacturing. And it's taken a decade, but those technologies are now, as we'll see in another slide, #1 in the industry in terms of acceptance and volume. In 2016, Qualcomm, which some of you might know, very significant leader in smartphones and other things, they decided they liked our technology. They invested in Deca, and they convinced ASE in Taiwan. ASE is the biggest packaging company in the world, as you might know. So ASE built a factory in Taiwan to implement Deca's technology for Qualcomm and others. And that started in 2016 and went to production in 2018. Raj is a little more aggressive. He wants 1 year versus 2 years. We'll see if we can do that. In 2020, we transitioned to a technology company where we transfer our technology to others. I should have mentioned at the beginning, we built a large factory in the Philippines where we created this technology together with our US headquarters. A company in Korea called Memphis took over that factory and continues to run it. Memphis is a big supporter of Samsung. They're one of Samsung's key outsource partners. In 2022 is the year that our technology became #1 in the industry in terms of this type of packaging technology. And we started introducing other folks like Skywater, which is a foundry in the United States, and Arizona State University, which is one of the leading universities in North America, is putting our technology inside a fab, and students, undergraduates, masters, and PhDs will be learning about advanced packaging based on Deca's platform. So, pretty cool. And if you're wondering our name Deca at the bottom, Deca comes from the Greek Deca, from the decimal system of 10. And what we do at Deca is, we like to say we have 10x thinking, meaning we're not a little bit better than others, we're at least an order of magnitude better. So that's where Deca comes from. We have some very impressive companies that are on our board of directors and own the company. Cypress was acquired by Infineon, a large company from Germany. So they're our largest shareholder. Qualcomm is second, ASE, Netflix, and Maxeon is what became some power. So we have multiple multi-billion-dollar owners of Deca. And we've received lots of awards. You can go to Google or whatever search engine you use, and you can see a lot of things that Deca has won in the industry. So as mentioned on the first slide, there's two fundamental technologies we created. The first is the M-series fan-out. And on that picture, the lighter gray color is a semiconductor chip. This happens to be a PMIC, a power management IC used in the iPhone. And you see the two solder bumps up on top. That's what hooks up to the phone motherboard or to the computer or the car. So our technology in this example is very simple, but it's mold compound around the die with interconnect layers and dielectrics that you can't really see in that cross section. Even though it looks very simple, there's a lot going on with the technology. And adaptive patterning is, again, the system that does real-time design during manufacturing, because often in manufacturing things move a little bit. So this allows the design to actually move with the natural variation of manufacturing. And on this slide, you see the iPhone-like part on the left. You see more complicated parts as you go across. And I think Raj will, RRP will hopefully be coming up with some of the parts on the left first to get everything up and running. But then as you advance to the ones on the right, and even more beyond that, you'll be in electric vehicles, you'll be in artificial intelligence, you'll be in a lot of cool applications. And speaking of cool applications, if any of you have an iPhone 14 or newer, 14, 15, 16, these parts are in your pocket. And if you have an iPhone 6, you have at least one part from Deca. So from iPhone 6 all the way to 14, our part count has gone from 1, 2, 3, 4, 5, and there's actually 6 in iPhone 16. So pretty cool. These are Qualcomm devices with M-series that have the patterning put around them. And you can read what they are, or you can't read what they are, it's hard to read. But they're power management chips, they're audio codec chips. And this one in the bottom with the red and green and blue lines around it, that's an envelope tracker. That's a key part of the RF signal. So when you're talking on your phone, it's optimizing the bandwidth, the band it selects, as well as the bandwidth and frequency of your communication to your cell tower to help optimize battery life and also give you a clear signal. So it's a very, very critical chip. We actually have one of those chips over there by the cameraman. So some of you'd like to see it. We really need a microscope to see it properly, but a real part from the iPhone is there. And then this slide talks more about the adaptive patterning, where we adjust the design during manufacturing. And if you look at the far, your right, again, is that one example device from Qualcomm. It's called a QBT7100. And there's a bunch of stuff on the internet about this as well. But that's a dual die part put together with M-series and adaptive patterning. And if you look closely at those pictures, you can see that the design is actually moving with the chips. But I think it's probably a little bit hard to see from where you all are. And my last slide is just to explain what's happening with this technology. So starting with the MCSP here on the left, that's what's in the iPhone, those type of parts. The one on the bottom, that's what goes in a Dell computer or some other applications like that. The POP, that you see at the bottom right, that could go in a phone as well, smartphone, as well as IoT applications, medical sensor applications for MRI and ultrasound and things like that. The MPQFN is a very interesting twist on our technology. So most folks in the world build QFNs with die-bond, wire-bond, mainframe technology. But with the fan-out technology, you can actually build it cost-effectively in a much more flexible way than you can with the old-fashioned QFN. And on the top right is a very, very high-technology version of our technology, and that's called MFIT, M-series fan-out interposer technology, and that's what powers artificial intelligence. So soon, hopefully by later this year, there'll be teardowns of one of the leading manufacturers in the world using this technology to put AI devices together, GPUs and memory. And we have more things coming in the coming years. So before I close, I want to just show you something. If later on when we have our break, if you want to come up and take a look. So this is an example of a real M-series fan-out wafer. You can see shiny silicon chips on the back. And on the front is a very planar surface with copper bumps coming up from the embedded ICs. And this is the start of the package. So as Raj mentioned, what RRP is doing is not really an OSAT, which is typically packaging. This is much more of a wafer foundry. And we're starting with some wafer fab processes. We do some assembly in the middle to put chips in a plastic wafer. And then we do a whole bunch more fab processes. So this technology is a very interesting integration of plastic assembly, a little bit, and a whole bunch of advanced fab technology. So this is what it looks like going into the fab, a black plastic wafer instead of a silicon wafer that we typically think of building chips. This is a finished wafer that isn't yet diced, but you can see all the chips on there with solder balls on the black, and the backside is black. So you can come up later and take a look at these. You can't touch them unless you're wearing gloves though, but you don't want fingerprints. But these are example M-series fan-out wafers that will be being built very soon. All right, so thank you all very much.
Deca is a global leader in advanced packaging, driven by a tech-based thinking culture.
Electronics and Deca Technologies. Congratulations.
Advanced packaging.
Congratulations. Congratulations.
I'm happy and I'm laughing because we already started this collaboration together and begun work. So this signing is ceremonial and it's very exciting for us. But we've already gotten to know each other and had the opportunity to begin this collaboration prior to this event.
Total sir, question to you that you have mentioned that this will be in Maharashtra. So which part of Maharashtra you are looking at the production?
So I think we are presently set up in Mumbai, but the state government has approved as a 100-acre land at Taloja. So that is where it's going to be a mix because at this point of time, by the time we get Taloja, it's going to be 6 months down the line when we take the possession of the 100 acres land. But we are in a hurry because we want to set up this. It's going to be a very unique, a very, very unique facility with the overhead transfer. Tim's products that go into the iPhone or into IoT devices, and Qualcomm has been, everybody knows that Qualcomm is a $19 billion revenue that is generated, but all these products require automation. So when we first discussed with Tim, looking into the cost, we decided to have a semi-automated plant. But then when Tim mentioned, that if we could build an automated plant, we could have businesses from reputed players like Qualcomm. So at that point of time, even without hesitation, we decided to set up a plant with the overhead transfer facility. So which means that when this facility is going to be ready, I always keep on giving very dates which are beyond the imagination. It's always fiction in it. Tim is also surprised, but we are going to do it. And when we do it, trust me, the state is going to be rocking. I mean, and we will create such a great impact. At the end of the day, our vision is to create an impact in the society, bring it back to humanity. And that's what semiconductor facility is. Many other industries define differently. We are into defense. We also trying to do a lot of things into compound semiconductors. We've got very good people from IIT. Some of the IITians are also sitting in this arena. But what Deca is going to do is probably going to take us beyond horizons. As I said, when people think of drone, we are thinking of satellites. The vision that Deca can bring to India, I mean, is out of the world. And time is, I mean, everyone's going to see it in the coming time. So that's where I'm quite excited about. We did tie up for memory chips, but I keep on saying this about Deca because it's something different than the others.
How thrilled, how happy you are with this joint venture and how you are looking at Indian market?
Well, we're incredibly thrilled. I could jump for joy, I guess, off the stage, but I might hurt myself. But we're incredibly excited. India is an amazing opportunity for the industry as part of the supply chain, obviously for all of you as residents and contributors. So I think I'm super happy that we're going to be involved with a hard-driving, visionary, aggressive guy like Raj and his team. So I think it's a really, really wonderful collaboration to bring technology to India and bring India to the forefront of the global supply chain for and others. Of course, Apple has to qualify with Qualcomm and everyone, but there will be a lot of interest from customers on that to come.
My last question to Ms. Rao.
Also, our team is very excited to have such a unique technology here, and we got an opportunity to execute it. So I guess we are going to try our best to start it as soon as possible.
Thank you.
First question, Sachin Tendulkar is an investor, answer is yes. Strategic investor, answer is yes. You would like to keep the extent of investments at the present moment on a silent mode, but Sachin Tendulkar sir obviously brings in the aura and the magical cosmic energies into the organization. And I'm saying this honestly because I've witnessed it. So when we approached sir, the idea was not to take investments from sir, but to take his advices, to take the energy that he can emit. And truly, he really emits energies. When you sit next to him, the aura is amazing. And we have ensured that Tim also meets him at some point today and bring him. But on many of them would be surprised to know that Sachin sir is playing a very pivotal role even in the understanding of the technologies, in the finalizing the right partner, and among all the partners that we have finalized, Sachin sir was very excited with Deca Technologies. He reads, he understands, and I think RRP is blessed with his guidance. Lot of developments is brought in. CBB Associates as our partners, who will overlook all our situations, and Priyesh is sitting over here. So these things that are brought in have created a system in RRP, and we have no hesitations in saying that after Sachin sir coming in, we are on the corporate level in terms of thinking, in terms of understanding.